You know, we wouldn't have built a telescope this big unless we needed to, and you need to build a telescope this big if you want to look at the very dimmest, most earliest galaxies in the universe.
The mirror is 6.5 meters, or 21 feet in diameter. And the problem with a mirror that big is it wouldn't fit in a rocket. So they had to build it in lightweight segments and figure out how to fold it up. The earliest, most distant galaxies in the universe can only be seen in infrared light. Infrared light is heat, and to detect it, the telescope must be kept very cold. It must be completely shielded from the sun, and that was a whole different kind of problem.
We don't want the telescope portion to see any of the sun. So this sun shield is a really, 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 really good SPF. It's about 1 million. What was particularly challenging is the fact that we have to fold it up and deploy it once we get on orbit.
It's an engineering marvel. The sensitivities and the requirements for doing the science correctly were so difficult that one would say it may not be possible.
The telescope was originally set to go to space as early as 2011, but things kept going wrong. The cryogenic cooler for one of the instruments failed. The sun shield developed tears. And at times it looked like the telescope might never make it to the launch pad.
When you accelerate from 0 to 18,000 miles an hour, you know, things can go wrong. So it's that constant thought, did we think of this? Did we think of that? Did we think of this? Because the slightest thing that could go wrong could actually mean this mission could fail.